This is Algebra 2, Unit 10, Lesson 9 on complex fractions. Now, complex fractions are simply defined as fractions that have other fractions within their numerators and denominators. So basically, it's fractions inside of fractions. Now, there are two ways that we can solve these. There is the longer way, and then there's the shortcut way. I'm going to show you both ways. All right, so the key is to be able to simplify it as much as you possibly can. All right, now, consider the complex fraction 1/9 plus 1/18 divided by 1/3. Okay, now this is just a numerical fraction that we normally see. So, what if we treated this like we would any other fraction? All right, now, if I want to combine these terms, right here, what do I need? If I'm adding two fractions, I need a common denominator. So I need to get this to be a common denominator of 18. So I want this to be 18, so I'd have to multiply this by 2 and this by 2. So that gives me 2/18. Plus 1/18 over 1/3. All right, so 2/18 plus 1/18 is 3/18 over 1/3. Okay, so I have two fractions now and I am dividing them. Well, division means multiply by the reciprocal. So this is going to be 3/18 times the reciprocal 1/3 is 3 over 1. And then you cancel here. This gives you 6. And then 3 cancels the 6, giving you 2. And that gives you 1/2. Okay, now that's kind of a long process, especially when you are trying to work with polynomials. So there is another way to do this. What you can do is look for the least common denominator amongst the three minor fractions. So if basically we're looking at the common denominator for the entire thing. The denominator here is 9, 18, and 3. What is the common denominator between those three things? The least common denominator? Well, it's going to be 18. Okay, now if we take this entire equation, we're going to multiply the entire thing by the common denominator. This is the trick shortcut to do this. Okay, I'm going to multiply this entire thing by 18, and I'm going to multiply this by 18. Okay, so 18 times 1/9, 9 cancels the 18, leaving 2. This one is going to be 18 cancels 18, leaving just the 1, because this is really 18 over 1. This is 2 plus 1. In the denominator, 18 times 1/3, the 3 cancels the 18, leaving a 6. 2 plus 1 is 3, over 6 is 1/2. Look at that, I got the same answer. Okay, so the trick here is multiplying by the common denominator. Just like we did with fractional problems, you multiply by the common denominator to get rid of the fractions, same thing. All right, now why is it acceptable to perform the operation in part B? Why could we multiply right here by the same thing? Because we are multiplying by the same thing. Technically, we're multiplying by 1. So multiplying by 18 over 18 in the numerator and denominator is really multiplying by 1. All right, so this is an acceptable trick. If you can remember, you have to find the common denominator of the entire thing. Otherwise, you'd have to combine the numerator, combine the denominator, and then divide. Both terms work. One is just a little faster than the other. All right, let's try another one. By multiplying the major fraction by the number 1 by using the least common denominator, we will always eliminate the minor fractions by turning them into integers. So that's a handy trick. If I want to do this, I want to multiply by the least common denominator for the entire fraction. So looking at this entire thing, all right, my denominators are 2, 10, and 5. What's my common denominator? It's going to be 10. So I'm going to multiply the numerator by 10. I'm also going to multiply the denominator by 10. All right, so when I multiply, remember this is really 10 over 1. So when you multiply 10 times 1/2, it is going to give you 5. 10 times negative 1/10 is just going to give you negative 1. And then 10 times 2/5, 5 cancels the 10, leaving a 2. 2 times 2 is 4. 5 minus 1 is 4 over 4, and this whole thing will equal 1. Okay, now, if you want to do it the long way, you can do it the long way. You'd have to do it this way. All right, you need a common denominator of 10. for here. So that would give you, you'd have to multiply by 5, so that would give you 5/10 minus 1/10. And this one, to make this into a tenth, would have to be 4/10. 5 minus 1 is 4/10 over 4/10. And that's actually the same thing, so that's going to equal 1. So you can do it that way too. It works. It's just a little faster if you multiply by the common denominator. Okay, let's try letter B. What is the common denominator for this entire thing? All right, look at your denominators. You have a 3, an x, a 3, and an x. So your common denominator is going to be 3x. So I'm going to multiply both the numerator and the denominator by 3x. All right, so if I do 3x times 2/3, the 3's are going to cancel, leaving 2 times x, which is going to be 2x. 3x times 2 over x, the x's will cancel, and 3 times 2 is 6. In the denominator, 3 cancels the 3, leaving just the x, so 5 times x is 5x. And then 3x times 5 over x will cancel x, and 3 times 5 is 15. Okay, so we have 2x plus 6 over 5x plus 15. All right, does that reduce? Well, let's factor it and see. Does 2x plus 6 factor? Yes, it does. It factors as x plus 3. And 5x plus 15, that will factor out of 5, x plus 3. So, what's common to both of these would be the x plus 3. So what are you left with? You're left with 2/5. And that's your final answer. Okay. All right, the trickiest part about this is multiplying by the common denominator. All right, let's take a look at the common denominator here. Here's my denominators. 8, 4x, 2x, and 4. All right, so what's the smallest number I could multiply all these by? Well, to become, they could all be made into an 8. But remember, there's also an x here, so your common denominator is actually going to be 8x. So I'm going to multiply the numerator and denominator both by 8x. All right, distribute here. 8x times 3, remember this is really 3 over 8, so this is 8x over 1, so this is going to cancel. 8 cancels the 8, leaving just 3x. And then 8x times this. 4x cancels 8x, leaving a 2. 2 times 1 is 2. Okay, this is really what I'm doing. 8x over 1 times 3/8 plus 8x over 1 times 1/4 x. So cancel, cancel, 3x, cancel, cancel, 2. 2 times 1 is 2. So I'm actually doing this in my head. That's what I'm actually doing. Okay, now for the denominator, same idea. 8x times 7 over 2x. The 2x cancels the 8x, leaving a 4. 4 times 7 is 28. And then over here, 8x times 3/4. 4 cancels the 8x, leaving a 2x. 2x times 3 is 6x. Okay, now let's see if I can cancel anything. I'm going to factor the denominator just to make sure. All right, 3x plus 2 doesn't factor at all, so I'm going to leave it as it is. And then 28 plus 6x, it factors out as a 2 times 3x plus 14. So does anything cancel? No, I can't cancel the 3x's because this has got something attached to it that's different. So that's as far as I could go. So this could be an acceptable answer, but I did factor just to make sure I couldn't reduce any farther. So there we go. Okay, so these type of fractions or problems can certainly involve more complicated secondary simplification. Don't forget the primary use of factoring in order to simplify. So basically, when you get down to the end, make sure you factor to make sure that it doesn't simplify any farther. All right, so we want to look at common denominators. What is my common denominator for my entire thing here? Well, let's see. I have a 2, and my biggest x is x squared. So my common denominator is going to be 2x squared. Okay, now sometimes it's easier to do it this way. Instead of putting the big parenthesis, what if we put 2x squared over 1 here, 2x squared over 1 here, 2x squared over 1 here, and 2x squared over 1 here. Because with little complicated things, sometimes it's a little easier to see what you're doing. Okay, so I'm looking at this right here. The 2 will cancel the 2. X squared times 1 is x squared. Okay, right here, there's a minus between them. X squared cancels x squared. 2 times 2 is 4. Okay? In the denominator, the 2x will cancel the 2x squared, leaving x, and then x times 3 is 3x, and then x squared will cancel x squared. There's a minus in here. Minus 3 times 2 is minus 6. Okay, so x squared minus 4, 3x minus 6, both of those are going to factor. X squared minus 4 is difference of squares, x plus 2, x minus 2. And then 3x minus 6 factors by GCF, 3 times x minus 2. Okay, so x minus 2 cancels x minus 2, leaving x plus 2 over 3. And that's as far as you can go. Okay. Let's try letter B. What's your common denominator? Well, it's going to be 5x squared. Because there's a 5 here, there's an x squared here, that's the biggest x that you have. So I'm going to write 5x squared next to each one. All right, so this one's going to be 5x squared. This one's going to be times 5x squared. This one's going to be times 5x squared. And this one's going to be times 5x squared. Okay, cancel, cancel. 5 cancels 5. X squared times 2 is 2x squared. There's a minus right here. X cancels x squared, leaving x. 2 times 5x is 10x. In the denominator, 5x cancels 5x squared, leaving x. X times 1 is x. Minus x squared cancels x squared. 1 times 5 is 5. Okay, factor, factor, factor. How does the top one factor? By GCF, not by double bubbles, because it doesn't have a third term. So your GCF here is going to be 2x, leaving x minus 5. The denominator is x minus 5, so cancel, cancel. You are left with 2x, and that's your final answer. Okay, let's try letter C. X over 12 plus 1 6 minus 2 over x divided by x over 12 minus 4 over 3x. What's my common denominator? It's going to be 12x. Okay, so I'm going to put a 12x here. There's going to be a 12x here and a 12x here. Okay, that's why I like to put big parentheses around it. I can see everything that I'm doing. And this is going to be times 12 over x, or I wrote 12 over x. What am I doing? That should be 12x, and this one should be 12x. Sorry about that. 12x and times 12x. Okay, so working on each term, 12 cancels 12, x times x is x squared. 6 cancels 12, leaving 2, 2x times 1 is 2x, and that's plus 2x. And then x cancels x, minus 2 times 12 is minus 24. 12 cancels 12, x times x is x squared. And then minus here, 3x cancels 12x, leaving 4. Minus 4 times 4 is minus 16. All right, factor, factor, factor. X squared plus 2x minus 24 is a double bubble. So that's going to be x plus 6, x minus 2. 4, not 2, sorry. I was thinking 2. All right. 6 minus 4 is positive 2, and then over x squared minus 16 is x plus 4, x minus 4. All right, what cancels? The x minus 4s. So you're left with x plus 6 over x plus 4. And there's your final answer. Okay, so if the denominators of minor fractions become more complex, factor them first, just as we did with adding and subtracting in the previous lesson. Okay, so my denominators here are x plus 2, x minus 4, and x squared minus 2x minus 8. So to figure out my common denominator, it would be helpful if I factored this first. So this is going to factor as x minus 4 times x plus 2. So that tells me my common denominator is going to be both of these, x minus 4, x plus 2, because I have an x plus 2 here, x minus 4 here. So when I do the common denominator on this, I have to do all three. So we'll finish these two in class in the next class day.